Okay, here we have question 4. Part A, on what open interval is the graph concave up? So we know that for concave up, you need to have the derivative of g be increasing. And since g prime g is equals to f, so we can just tell from the graph that from intervals -4 to -2, and from 2 to 6, that f is increasing. So g prime, so g is concave up. Part B is the p the function b. First write out the equation p of x to g of x times f of x. Since we are trying to find the derivative, so p's derivative of x equals to so it's g derivative x f of x plus g of x f prime of x. And this g prime of x is just f of x, so it's f of x squared plus g of x times f prime of x. Plug 3 in. 0 plus 3 f of t dt times f of t prime 3 will give you -3 squared minus 3.5, which is equal to 5.5. Or part C. So g of 2 is equals to which, look at the graph, it's 0, and since x squared minus 2x when x to 2 is also equal to 0, it's also equal to 0, so the function will just plug the 2 in, it will give it 0 to 0, so we use the L'Hopital's rule. So we just take the derivative from both the top and the bottom, so it's just f of x over 2x. So it's just, hold on, the limit of x goes to 2 of f of x 2x minus 2, which will give you -4 and 2. It's just -2. Part D. Find the average rate of change. It's just g of 2 minus g of 4, -4 over 2 minus -4. It's just 0 to 2 of ft dt minus 0 to -4 ft dt over 6 will give you 16 over 6, which is equal to 8 over 3. And so we know that the graph f is continuous, so we can say that g of x is also continuous. And since since the g of x is differentiable because it has all the value for the derivative, use mean value theorem, which suggests that g prime of the x, which will happen to be some value of g that will equal to this equation, the average rate of change, which is also equal to 8/3/3.